SI units is Newton M. Now, another thing I have told you earlier, that the force, actually I have denoted it here in terms of the scalars, but actually force is a vector quantity. It's also a vector quantity. And I told you earlier that change in the momentum is given by the change in the momentum. Direction of the change is actually given by the force applied. So that means it's a vector quantity. It can also be in the Cartesian coordinates. Suppose this is y-axis, x-axis, this is z-axis. If on a body we apply some force, it can be determined in coordinate system with 3 components. Any force on a body, this m into a, it can be represented. Generally, it is represented by Fa like this, but component wise, it can be represented as the force along the x component will be Fx, represented by mass. Mass will be the same, because mass is not a vector quantity. Only the acceleration is a vector quantity. So the acceleration along the x-axis. Similarly, force along y-axis is given by mass times the acceleration caused in that direction. Similarly, the z-axis. And this means that, I write it down, it's a very much important here. It's a very much important fact that if a force is not parallel to the velocity of the body, if the force is not parallel to the velocity of the body, then it changes that the force, then it means the force, it changes only that component of velocity which is along the direction of the force. Okay, that means the forces which are the velocity components which are perpendicular to the direction of the force remain unchanged, and the component which are normal means perpendicular to force remain unchanged. What does that mean? For example, we have a coordinate system, xy coordinate system. Here it's x, it's y. Suppose here is the body, possessing mass m, moving with velocity something v, suppose, and it's moving along the x-axis only. Suppose we are applying a force upon it along the x-axis only. That force acting upon it is along the direction in which it is moving already. So that means this says that force which is not parallel to the velocity. So here it possesses Vx. Suppose in this direction is Vy, but here in this case it's 0. Force is acting only along the x-axis. That means this force will not bring any change in this Vy. There will be no change. There will be no change in the y component of the velocity. Suppose our body is moving like this. It possesses both Vx, possesses both Vy component. Suppose I am now applying a force along this direction, that is Fy direction. And this very force causes a change in the momentum, causes the change in the velocity, that is the acceleration, but the force will the action of the force will only take place along the direction of the force, which is here the y direction. That means along this direction there will be no change. That means the perpendicular axis to the applied force have no effect. That is what I quoted here. If a force is not parallel to the velocity, that means velocity this is not parallel to it, is perpendicular to it, it does not change in the velocity, but it changes only that component along which the force is acting, that's Vy component. Okay, and the another one from where force is not acting, that remains unchanged. Now, same effect can be observed in the projectile motions. What does projectile mean? If we are standing at some height on a tower and we have a ball here exerting some force over it in the direction of, suppose we are here, we are applying a force in the direction, say this is x direction and this is y direction in this case. Okay, now we are exerting a force on this body, along this. So the component force or the force is applied in which direction only? The x direction only. Okay, so that means the y component will remain unchanged in the first place. But as long as the force is out, so now body reaches here, say, now no force along x-axis, no force along x-axis, fine. So no force is along x-axis now, because it is now in a free fall. But here comes in action the downward force, which is the gravity. So the force will be mass times the gravity, fine. So but the action of the force is along what direction? In the y direction. That means the x component, which was the velocity Vx, the x component of the velocity will remain unaffected. Vx will not change, only the Vy will change. Here will be the Vy will be V1y. Here in this case Vx will be same Vx, but the Vy will be V2y. Here x component will be same Vx, because the force is not acting upon the x-axis now. Here gravity is acting downwards, that's y-axis. Here again y-axis, here again y-axis. That means the y-axis will change the velocity. The y-axis force will change the velocity. This time y3, v3y. Okay, that means the change in the velocity is determined by the force in the direction in which the force is applied. Only in that direction the velocity will be changing, and the perpendicular direction there will be no change. Like there, here is vx, here is vx, here is vx. No change in the velocity, because force is not acting along x-axis, it's only acting along the y-axis, and here the force is gravitational force. So that means if we have a force which is not parallel to the velocity, okay, which is not parallel to the velocity, it changes only that very component of velocity in which the force is applied. That means force is applied in this direction, that means only this very component of the v will be changed, that's Vy will be changed. In this case Vy will be changed, in this case Vy will be changed, but Vx will remain unchanged. And another thing is that the force is as if force acting on a body is as if its point of action, I will here write it down here for rigid body, okay, for rigid body, that is system of particles which are confined to a particular space position. For rigid body, its point of what I told you, force acting on a body is as if its point of action is the center of mass. center of mass. For example, this is a body. It has got many particles inside it. It's a rigid body, and say its the center of mass is like this. This is the center of mass. If I apply the force onto it, F, the force will be acting on this body as if it is only acting upon this point only. This is the center of mass. For example, if I suppose this is my pen, I have to balance it inside my hand. I can possess it right here, like this. It is balancing. That means I am exerting a force against the gravity right now, because if I pull my hand back, this will fall down. That means the gravitational force is counterparted by my hand force, the force of my hand. So, but the action of my force is only one point, and in this case, the center of mass is at this tip. So, although the body is huge, but the force is acting as if it's acting only on a position which is the center of mass. So the force of action on a rigid bodies is treated as if it's acting on the center of mass. Another thing, the last thing which is important note.